Hi, my name is William Ryback. I'm part of Group 30, and I'm here to talk to you about Rescue 1, our company. So let's get started. First off, let's talk about the group members. There's me, William Ryback. I'll be talking first about our problem solution and an introduction to our product. And next we have Tyler Feldman. I'll be talking to you about our development process, a little more in-depth technical detail on our product, and give a little bit of information on our plans for manufacturing, setup, that sort of thing. And finally, there's Aleda Perez. She'll be taking care of financials for you, and you know that's the important stuff that everyone's care about. But for the time being, let's get started. So first off is our problem. People die every year due to lack of emergency signaling devices. Now, the way we came about wanting to solve this problem is the fact that a couple of us in this group are what you consider outdoor enthusiasts. And we do understand the importance of having the ability to signal search and rescue when in distress. So we did a bit of researching and we found out that there is a solution currently. The solution is called the Personal Locator Beacon. Personal Locator Beacon is a handheld device that is initiated by the user, and when initiated, it sends this current location through GPS coordinates through a system of satellites and receiver stations to search and rescue so they can come and find you. Now, if you look down in the right hand corner, it gives you kind of a brief little flow chart of how this works. And the product works pretty well. There's a lot of manufacturers out there that are making this product, and they're relatively cheap, at around $300 price range. And these current generation personal locator beacons do what they say. They provide GPS location to the authorities, and they're handheld, compact size, so you can carry them with you when you're out hiking, biking, traveling, doing stuff off the beaten path, away from help. I found a couple downsides with the current generation of personal locator beacons. First being, the signal can be affected by obstructions. Canyon walls, mountains, tree canopies can interfere with the signal and make it almost impossible for the signal to be transmitted to the receiver. Second off, it's still difficult to locate the user in the general area once search and rescue has been sent your location. We came up with our solution. We named it Hermes Beacon. Now, it's essentially a personal locator beacon. It does the same that the others do. They transmit GPS location. But we've added two important and innovative features to our product that puts us above and beyond everyone else. First off being the inflatable signal balloon, also the transmitter carrier, and the LED Morse code signaling on the carrier. Like I said in the previous slide, these innovative features that we've added to the personal locator beacon is what sets us apart. First off, by being able to lift the transmitter above the obstacle, we're able to increase the range of the signal by increasing the line of sight of the signal. Second off, by having a large lit object floating in the air, we've obviously increased the visibility of the user. Now, by increasing the range of the signal and increasing the visibility of the user, we therefore increase the chance of being rescued. So, in the past few slides, I've given a description of the features that make our product better. And so how do we enter a market and maintain our competitive advantage? Well, we're going to enter the market with a superior product with superior functionality to our competitors at a competitive price point, being at or below the current market value of these personal locator beacons. Second, we plan on maintaining a competitive advantage using IP protection, such as patents and trade secrets, and also maintain goodwill. As being an enthusiast company, we're going to be made by enthusiasts for enthusiasts. Now, I'm going to pass it over to Tyler, and he's going to talk a little bit more about the design phase and a couple other odds and ends of our product, but it was good talking to you guys.
Once we decided we had an idea for a marketable product, we used a development process to put this idea from concept stage into production. We started with a pre-concept, then moved to concept, preliminary design, detailed design, testing, and finally production. First, we started with a pre-concept design where we came up with several ideas for this project, and once we determined which idea we wanted to move forward with, we came up with several different conceptual designs and organized them and ranked them to see which concept would work best for this idea. In the preliminary design, we took our previous model from the conceptual design and made various refinements and additions according to the different concepts that we came up with. This shows our CAD model of what we came up with in the preliminary design. This rendering of the CAD model shows that we made various improvements over the preliminary design. This figure shows an exploded version of our product. First, the gas canister holds high pressure gases, specifically helium. The helium is then transmitted to the valve mechanism, which releases and inflates our balloon. The electronic housing holds the GPS receiver, FM transmitter, and SOS LED light. On top is a compacted mylar balloon. The animation shown here represents our operation of our device. The lid is lifted, the electronics are engaged, a pin is activated, and then the balloon starts to inflate. Once the balloon reaches maximum inflation capacity, it starts to rise out of the housing and carries the electronics with it. The electronics are attached to the housing with a tethering cord. Once we were happy with our detailed design, it came time to rapid prototype our device. We did this through a 3D printer, shown in this video here, and also a CNC mill used to machine our valve mechanism. This picture represents our current stage. We have a rapid prototype housing, and we also have various components manufactured. And now it is time to further develop our model and then eventually set it into production. In the future, we plan on producing our product. So we have to have a refined model through rigorous testing. And then we plan on focusing our manufacturing process for low startup costs. Now we can do this because we have already completed much of the research and development. We plan on outsourcing a lot of our machine components and then assembling everything in-house.
General assumptions. Our business will only market a single product. The product is primarily designed for individuals operating in remote areas, which is a niche market. We expect a large expansion within the outdoor hikers and remote areas such as backcountry mountains, avalanche-prone areas in oceans, and government organizations. As we had mentioned before, we expect a large market size with promising conditions. So far, we have not identified a competitor to implement both GPS signal location transmission and inflatable high-altitude visibility. No changes in cost of goods sold. We would like to improve our product and see the response of our customers with customer feedback. Income statement. As a startup company, we do not expect a high revenue due to not many units sold during the first 2 quarters. The product will be sold for $299.99, and an increase of 20% of units sold monthly is expected. Expenses. We estimate $158.50 expense for each unit sold. The fixed expenses include sales and production salaries as well as labor salaries. The sales and production increased from $50,000 to $100,000. And the labor salaries increased from $175,000 to $350,000. Our final net income stays positive. Here we demonstrate the income statement table. And here the graph. This graph shows positive gross revenue, expenses, and net income trend lines. We can see high revenue and low expenses, which means we have a positive net income and return of investment. Return of investment increases since the start of the business. The revenue is always higher than total expense. Balance sheet. Assets. Our fixed assets are $220,000, which are constituted a 5-year period. We maintain $30,000 in cash at year 1 and $40,000 at year 2 through year 4. Our inventory are kept at 20 units at year 1 through year 3, and 50 units from year 4 through year 5. Liabilities. We have low number of accounts payable at year 1, and at year 2 increased dramatically and kept increasing to year 5. Our debt. A total of loan of $23,600. It's a 60-month loan with 18 fixed interest rate and a monthly payment of $507, which we will begin paying at the 7th month. Our total equity is positive. And here our balance sheet. Cash flow. The net income was adjusted by subtracting a 20% from the total income. Here are the cash flow table and diagram. Usage of funds. We approximate a cost of $200,000 for research and development. Using third-party companies for production, a low cost was kept at $20,000. Entrepreneurs raised $50,000. A bank loan we acquired for a 16-month period at $20,000 with 18 fixed interest rate. Here we demonstrate a table with the usage of funds and percentage as well as schematic of the usage of funds. The funds will be mostly used for research and development, salaries, and investment. These three are the primary objectives for our company to commence and grow. The two other sources, such as other and outsourcing, are not our primary goal for the usage of funds for the first 5 years. But we do keep in mind these sources for our business to grow and expand.